Hello, my name is Yaya. This is another video on using HTZ communications or HTZ warfare for tunnel modeling this time. I'm going to show you how you can build a tunnel from scratch. So let's go ahead and show you what I have as an input. So as an input I have shapefile. So let me show you what the shapefiles are. So this is a QGIS, it's a free tool. We can open GIS data. So GIS data I'm referring to is, in that case, is this one. So just do by shape viewing, and then you can see here, you can open it, and you can see this is a tunnel underground. Okay, so this is the rail track, the center line. Obviously, there's a couple of these files in here. I'm just going to load all of them for now, just to show you what you're up against. So have a look. So if I zoom in, you see there's two tubes or two platforms here, two tracks. Probably you can see the center line, and you can see the tube. So in fact, I received only the center line, and I had to convert it into a polygon. There's a function in this tool to buffer the line to the left and to the right, and to build a polygon. So these polygons are the minimum data you need to have available before you go ahead and build the tunnel model in the software. Okay, so this is what you have, and you want to do RF predictions like Leaky feeder in a tunnel environment. So step number one is you need to go and run ICS map server. This is GIS software, and I'm going to create what we call a blank matrix from two corners. So I'm going to use 0.2 centimeter, which is 20 centimeters, and I'm going to load the canvas. I built a canvas just to establish the boundary of the area. And you need to convert this this one is a 4-deck, which is WGS84, is 7 degrees. I need to convert it to the grid system for that area, which is 4 ATS 56 in my case. So you can communicate with us to know more about the coordinate system for the area you want to work with. Okay, create. I'm going to save it as a 16-bit file, save it here. So this is the tunnel model, and at this stage it's 20 centimeters, and it's based on 4 ETS 56 for the area of interest. So you put here 4 ETS 56, enter. Done. Now you open that file in a control treatment memory session, cancel this, and then you open the IC2 file, maximize, left click, right click, and now you click on this one, rasterize, vectorize, and then you open the buffer, so the one that you buffer the line. Now before I do that, in fact, you should choose here in the parameters a default value. So I'm going to choose 0, which means open for the tunnel itself, and I'm going to now rasterize using my ESRI shapefiles, the buffers. So choose first down, click anything here, say fill, and then use a flag value, the flag that I defined here. And this source is, in my case, 4 ETS 56. The file I saved is 4 ETS 56. Here we go. And I repeat the process, but this time for this one, uplink, filled, and then here use the flag, and then 4 ETS 56. Here we go. Click. So now you see this have a 0 here, you can read the value. This has a 0 value, this have a negative value, negative 9. Now for indoor modeling, I advise you keep the 0 as 0 and then the minus 999, you change it to 10. 10 means non-penetratable. So I hit OK. Now you see, now this is open, this is 10. So you save now. You save it, and you can save it as any format. I would advise you to save it as different extension as ATDI, indoor, raster. Save, done. So now I have a raster file here for the indoor modeling. This is just a blank matrix. I can delete it. I don't need it. Okay, and I need to have an image. So what I'll do, I'll just probably borrow an image from somewhere else later on. You run now HTZ. Go File, Project Manager. This is ATDI. Alright, it's done. Look, so you could reuse that same image here. So in fact, just remove this and remove the PRM, and on the palette here, I mean on the terrain, double click, and you navigate to your IDR and save the project. Overwrite no, I'm going to save a new copy. So we call it here, we call it tunnel, Leaky feeder tunnel. So see, I reuse the image and I have new IDR. Now open the project. Here we go. So this is the image for the area, and you can click the layers here, and then you can see the image plus terrain in a grayscale, or in a black white, or let me show you, or color palette, or gray. So I'll choose this one. This one have a good contrast. So zoom in. So that's how it looked like. So this is going underground, so you can't see it on the image itself. Just to show you also the terrain, this is the terrain. So it's a flat terrain effectively. Of course, there's curvature for the earth involved, but this area is all 10 meter. This area is all 0. And in the tools here, indoor parameters, you will see actually we have codes. So 0 means no effect, it's open, and 10 means non-penetratable. Now, if there's more materials, of course, you can model the materials, but I choose to use 1 and 0 at this stage. So here we go. I'll just do some quick settings to confirm software is configured correctly. Not the clutter, tools, application model, settings. So you see automatically software is on the visible. In visibility or indoor coverage. So let's go ahead and model a leaky feeder maybe. You can put the image back in if you want. Doesn't bother me. What I'll do, first use the path mode here, and then you click here. Okay, so you can go in one direction. When you finish, you can switch back to the TXRX mode here, and then you can go to path parameters, and then you can choose above ground level here, and then you can set up your source, your transmission source as 2 watt, and your transmission frequency for 50, for example. Antenna height is going to be, for example, 3 meters. Pattern, you make sure and we can come back to these parameters later on. Close. So now we have a leaky. I'm just going to double check my settings here. So I'm going to use, for example, here neg 85 dBm as a sensitivity. And you go to now coverage, network calculation, and leaky feeder coverage. Before you do that, actually, just make sure your distance here is limited to 0.005, 5 meter, and do the coverage calculation. So this is the linear loss. This is the coupling loss. This is the standard distance used by the manufacturer when producing the coupling loss and the linear losses. Curves, and then here we have sampling. So every 1 meter across, every 1 meter along the leaky feeder, the coverage will be predicted every 1 meter. Here we go, coverage is being predicted. All right, here we go. So in fact, this is the signal along the journey. So starting very hot, very strong. It starts from here, point number 1. That's where the 2 watt is applied. The signal is degrading as you go further and further and further down the line. So it's degrading in distance along the line and also away from the line. Because it's switching down to neg 60 dBm in that case. That's neg 60. Of course, that line can run a little bit further. Now, the FLD or the coverage can be saved. File, save FLD. This is how you can save the coverage. Alternatively, you can just create a dummy station somewhere. A dummy station. Now, that station ideally would be on the same frequency. And we call it a dummy. And if you click on that station, select it, you can go attach the coverage. So the coverage that you see here as a leaky feeder, it's now part of the station. So if you lost the coverage, it's enough to do Control-C to bring the coverage back in. Okay, so you can see the coverage is now back in. Now you may want to run more of these cables, leaky feeders. So you can try to switch back to the path one, and you see the moment you click, is not going to allow you to make a new one. So it's always starting from the end. So the advice here is to you could make another one. Just completely forget about this one. You click on this one here, for example, and then you remove the graph. Remove or remove path. So now we can make another one. Now remember, the coverage is saved for this dummy, station number 1. So now we can just do it again. So start from same spot. Okay. Now I'm assuming every split have a 2 watt. Of course, something you can change. All right, done. Escape to switch to the TXRX mode, and now go to the path parameters again. Path parameters, and then just make sure everything is all right. So everything is the same parameters still, so no problem. And now you go to coverage, network calculation, leaky feeder. Yes, remove the memory. Or you can keep the memory if you want. So if I do it again, if you choose to, it's already deleted. Sorry, but you could have left it. You could have left the memory, and then you can do the other one. This way, it will be one coverage. I prefer if you save every cable direction as a separate station coverage. So this is done. So what I'll do, I'll create another dummy station anywhere. So this is going to call it dummy 2 and 450, yeah. So this one I'll call it dummy 1 maybe. And now again you click on that station before you lose the coverage, and then you do attach coverage, yes. So now even if I reset, so Control C, you see now I have both coverages in one display. I can forget about that path. Where's that path? So you click on the main one, remove path, yeah. You can remove the path. So Control C, you still have the coverage. Now, if you want to plot, the signal, you could also plot the signal as a graph. Sorry, I accidentally dropped this one. Escape. Okay. If you want to get the signal along the journey, you could. There are functions in the software to do just that. So for example, you might have a vector layer, new vector file, and let's call it vector. And you might have, you can import it from, let me draw a polyline, draw vector line. So this is a vector line. A vector line can be used to simulate a train on the move, for example, and then do analysis such as handover analysis or a signal level analysis or best server analysis. So if you want to analyze things in line fashion instead of a heat map. Okay, continue, add polygon to vector layer. So line example, activated, make it a bit thick, and here we go. Now we have a line. Now that line allow you to do some analysis. For example, should be able to do vector line coverage, for example, vector line graph coverage along vector line. If I choose this one, move to the nearest, no, don't move it to the nearest. Max distance, or what about it, as if this is -1. There we go. So you can see the journey starting from here, which is from down, from the lower part. So signal was considerably less than the maximum. The signal is enhancing, going up until you reach the middle. Here, that's the feeding point, and then it's going down again. Okay, and you can list these results. You can get them in dBm or something. You can even do Control B here, best server. So you see best server, showing you where is the best server from this or from that, and you can get the signal level for sure. So go to map, vector layer. Go to the coverage network analysis, and then you can do network report. Here we go, vector line. I use best server now. So I've got a list. So this is the report that produced. So let me just clean it up a bit. Data, text to column, sorry, text to column, next, so semicolon. Alright, so you've got here the station name, station number, station name served along the journey. This is the distance from starting point 0, 0. Okay, that's the distance. So because this is doing every 1 meter, so you can see here the signal level in dBm. and you can see the best server name, so dummy 1 and dummy 2. They both will be here in the report. Now remember, I used 1 meter as a step for the analysis. Here you go. So this is the power saved, and this is the server. So you can export the results, Control C again. You can apply a legend if you want to apply a legend. You can apply a legend. Okay, I think I'm going to stop for now. You have a good idea now, roughly, how you can do Leaky feeder modeling and analysis in the tool. Thank you, and talk to you soon.